question looks interesting. Let's see. S is the set given to you, and X be set of all relations. Okay, what kind of relation? From S to S, satisfying these properties. Okay, number one and number two. Number one says that the relation has exactly six elements, and number two says that if A is related to B, then you should have that the difference between the elements should be greater than or equal to 2. Now, what is a relation? Like you have a set here and another set here. You have to have from S to S. You already know that S has 1 to 6 elements, and here also 1 to up to 6 elements. Okay. You want to have a relation. Normally, what is a relation? Like any element can go to any element, right? One could go to 1, 2, 3, okay, up to 6. Similarly, 2 can go to any one. Okay. But what do I want? Who are the possible candidates, okay, to be in a relation R? You see, this should be satisfied. Okay, so can you start relating 1 to what number? Okay, from here 1 cannot go to 1, right? Because the difference is not more than 2. It cannot go to 2 also. It can go to 3. Okay, because the difference is 2. Okay, so it can go to 3 or it can go to 4, right? It can go to 5, it can go to 6. Okay, like that you have to list all the possible candidates who can be there in a relation. Okay, so let's list them out. Okay, 2 can go to 4, 5, 6, right? 3, 5, 6. Can 3 go to 1? Of course, right? Because the difference is again greater than or equal to 2. Okay, 4, 6. 4 can go to 1, 4 can go to, that's all. 5, just list patiently, okay? 5 can go to 6, no, right? You have to start with a 1. 1 and then 2 and then again 3, that's it. Okay, 6, 1, 2, 3, 4, that's all, okay? You cannot have more than that. So how many elements do you have? Can you count here? Like 4 and 4, 8, and the remaining is 12. So there are 20 elements you can count here. Okay, there are 20 elements. Now, how many relations can you form from these 20 elements? Okay, because see, there are exactly 6 elements. So from these 20 elements, the number of ways you can pick any 6 of them. Okay, that will be a possible relation. Yeah, so that would be your number of relations, or X be a set of all the relations R. Okay, so number of elements in X would be how much? All such relations. Okay, so 26. Okay, let's read the question more. They are also defining what is Y, what is Z. Okay, Na denotes the number of elements in the set A. Then they are looking for how many elements you have in X. Okay, they're saying MC6. Then what is M? Just now we said, right? 20C6. So your M is how much? 20. Number of elements in X is 20. Okay, now what is the other one asking? Other one asking is number of elements in Y and Z. So let's read what are Y and Z. So Y is again all relations in X, okay, such that the relation has exactly one element. Now one more condition, okay, the again possible elements from here only, okay, but the range has exactly one element. Okay, can the range has exactly one element means what? Suppose the range has only one. Okay, so range is one, that means these are the possible candidates. Can you see there are only four? But I need to have exactly six elements in X, in R, exactly six elements in R, right? So there is no such R, right? Even if you check with a 2, you have only 3. You check with a 6, you have only 4. So there is no relation in X, okay, such that range of R has exactly one element. Okay, so for that matter, the number of elements in Y will be what? 0. Okay, there are no elements like that. Okay, there is no relation such that this is going to happen. Okay. Now look for your Z. Okay, what is your Z? Relation in X such that R is a function from S to S. Okay, so what makes a function? Okay, R is a function you want. Okay, function means what? Every element should be mapped, right? 1 should be mapped, 2 should be mapped, 6 should be, everyone should be mapped. But this is not possible. Okay, one cannot go to more than one. Okay, one has to go exactly unique element. Okay, so that means what? One can go to either of the four. One has four options to go to. Yeah, 2 has how many? 3 options to go to. Similarly, 3 has 3 options. 4 has again 3 options. 5 has again 3 options, and 6 has 4 options. Okay, so these are all possible options which you have to form a function. So what will be number of elements in Z? The product of all of them, right? You can have any of them. Okay, so let's have it. Okay, so uh, 4 into 3 into 3 into 3 into 3 into 4. How much is that? This is 4 square into 3 power 4. Okay, now what do you want? You want ny plus, right? Does it changes anything? No, ny is 0, right? Okay, so this they have given you is k square. Okay, then they're looking what is k. Yeah, take the under root. So your k would be 4 times 3 square, and how much is that? 36. Okay, so number of elements in k is 36. Okay, interesting question. Depends on just the definition of relation and function. Yeah, see you with another question.